Okay, so for today's lesson, we're going to be looking at graphing sine and cosine. Now, we are going to just be looking at, we're going to start with the parent functions and just reviewing you on what those look like, and then doing very basic graphs with just the transformations. In pre-cal, you got very in-depth and you used, you graphed pretty intricate graphs. For this course, we're just going to do a quick review and do very basic transformations with them. So to start, we're going to look at what does the parent function of cosine and sine look like, and then do the transformations to those graphs. So to begin, just a little review on this. If you remember with cosine and sine, with the parent functions, we labeled the x-axis by pi over 2's. So we counted by pi over 2's because remember we used those quadrantal angles to start. And then sometimes this x-axis will change depending on the transformation we're doing. But for the basic cosine graph, this is going to be, that's what the x-axis is going to look like. Now cosine always starts at the top, and so our starting point is right here. And we, then from the top, we went through the middle, bottom, middle, back to the top. We had those dashed lines. I'm not going to put those dashed lines in here, but remember we had points on our top line, middle line, and bottom line. So this would represent one period of the graph, and then going the other direction, we were at the top, through the middle, bottom, back to the middle, back to the top. Like that. So that is going to be our parent function for cosine. Again, remember this starts at the top, and we're labeling our number line like this for the parent function. That x-axis might change if we do transformations to our x. Now let's look at sine. Sine is going to have the same labeling along the x-axis. So let's go ahead and get our x-axis labeled. Cosine started at the top for the parent function. Sine starts in the middle. So here it's going to start at the origin. As we graph to the right, we're going to go up, and then back to the middle, back to the bottom, and then back to the middle. And that pattern will continue. Just looking at that, there's one period of the graph. I'm going to go the other direction, so I'm in the middle. But the point prior was at the top, so it's like top, middle, bottom, middle, top, middle. And that, of course, goes on and on and on into infinity. Okay, so there are two parent functions that we'll apply transformations to. So we'll do basic shifts, left, right, up, down, reflections, and then some stretches. Okay, so let's look at this one. This is y equals 4 cos x. This 4 out front, just kind of a little review on transformations. This will be a vertical stretch by 4. So this is not changing our x-axis. So let's go ahead and label this like we did. We'll see an example of where this does change. But this transformation isn't changing anything about the x. Okay, so I'm going to put little x's here for the original points. And I'm just going to do the transformations to these points, and then I'll just kind of continue the pattern and finish it to the left. So that is going to take this point, I'm going to start with this point right here, and it's going to quadruple the y value. So my y value is at 1. If I multiply 1 by 4, I'm now at 4. This point right here, my y value is 0. If I multiply 0 by 4, it's still 0. For this point right here, I'm at -1. If I multiply -1 by 4, I'm at -4. And then here I am back up here, I'm at 0. My y value is at 0. If I multiply 0 by 4, I'm still at 0. And then 2 pi is going to do the same thing that this point did, where it stretches up here. Like that. So then our points are just going to follow that same pattern this way. And then we'll put our arrow on there. Okay. So there is y equals 4 cos x. Okay, so for this one, we have y equals sine x minus 2. This minus 2 at the end is going to shift down 2 units. So this isn't changing the x-axis, so I'm going to go ahead and label it like we have been. Okay, and put little x's on my graph for the sine parent function. Okay, so remember sine starts in the middle, and then we went up, middle, bottom, middle. All we're doing to these points is shifting them down 2 units. So this point right here, 1, 2, lands right there. This point up here, 1, 2, lands right there. This point goes down 1, 2, lands right there. This point goes down 1, let me extend this, 1, 2, and then this point goes down 1, 2. And we can see our graph like so. So I'm just going to continue that over here. And finish the graph. This one should be a little higher. There we go. Okay. Okay, y equals cos 3x. So we are manipulating the x here. We are doing a transformation to the x. So our x-axis will possibly change how we're scaling it. Remember, when we have a multiplier with x, it's always the opposite of what we're given. So instead of times 3, you're multiplying by the reciprocal. So times 1/3, or divided by 3. So instead of times 3, it's divided by 3. But we're going to, this is a horizontal compression by 1/3. So we will multiply the x's by 1/3. So the original number line here was pi over 2, pi, 3 pi over 2, and then 2 pi. I am going to multiply these all by 1/3. And that is how I will scale it for this problem. So this will be pi over 6 when we do pi over 2 times 1/3. Pi times 1/3 is pi over 3. 3 pi over 2 times 1/3 is pi over 2. And then pi over 2 times 1/3 is 2 pi over 3. Okay, and then just going the other direction, it will just be these but negative. This is the only transformation. So I can just put the points, how we laid the points for our parent function on our graph, like where sine starts, no, this is cosine. Where cosine starts at the top, goes to the middle, bottom, middle, top, and then go the other direction. I can just fill these in, and I've done the compression by adjusting my x-axis. And there's our cosine graph. Okay, let's try one more. Here is a horizontal shift of pi over 2. So, because I'm counting by pi over 2s, this isn't going to change the scaling, but typically what we do is this is our starting point, and we go, if we take all those points, or let me just label it this way for now. Okay, so sine starts in the middle and then goes up, middle, bottom, middle. So this is shifting it to the right, pi over 2. So here's the parent function for sine. If I take this point and I shift it to the right, pi over 2, it lands right there. This point, I shift, it lands right there. That point lands right there. This point lands right there. And this point lands right there. So I'll need to label this tick mark, which I'm adding pi over 2s. So this is going to become 5 pi over 2. And so there's that. Going the other direction, we're top, middle, bottom. Middle, top, middle. And I can just do 4 points from my starting point. So I can just label these points. Since I added this point here, I don't need to worry about that. We can just graph like so. And there's the sine graph shifted to the right, pi over 2.